Hi students, today I am going to explain in electrophilic aromatic substitution. We already did one video before, that is part 1. You can refer in my channel, and this is part 2, next part. So let's see. So there are different types of electrophilic aromatic substitution reactions. So basically we are given 5. So what are they? First one is halogenation reaction. So halogenation reaction. Second one is nitration reaction. Third one is sulfonation. Fourth one is Friedel-Crafts alkylation. Fifth one is Friedel-Crafts acylation reaction. So all these reactions will have a similar mechanism with only very little differences or minor differences present in this. So we can understand first the general mechanism of all these and individually too. So to understand the electrophilic aromatic substitution reactions, let's see first. So benzene ring, we come with the benzene ring. When we talk about aromatic, we remember the compound benzene. So benzene, when it is attacked with the electrophile, so it is called electrophilic attack. Then it becomes a carbocation. So for this we want a strong electrophile. Why we want a strong electrophile? The reason is because benzene, so it is an aromatic compound which is a very strong, stable, strong compound. So we have to break its bond, pi bond, to form a carbocation. So for this we want a strong electrophile. So generation of a strong electrophile is a main step, first step in this process. So the electrophile will be attacking to the benzene ring to form a carbocation, and it is a resonance stabilized product. So it is a carbocation is a resonance stabilized, and it is also called sigma complex. Let's see here. So we can see 3 resonance stabilized structures here, 1, 2 and 3, and this is also called sigma complex. But now here they are not using sigma complex word as it is outdated. Before it was using, but in some textbooks we can find this term. And after this resonance stabilized sigma complex or carbocation is formed, after that the next step is removal of proton. So the proton will be removed and electrophile will be attached. So this is the final product we want. Here when making a carbocation, so what happens when a carbocation is formed, it loses its stability as well as it loses its aromacity also. Why? Because while breaking the bond to while the electrophile is attacked to the aromatic ring, its bond is broken, so it will lose its stability and aromacity. So to make it again aromatic, it will lose a proton attached to it, so to the electrophile, and this proton is acidic or weakly acidic, we can say. That is why it is a substitution reaction. So simply we can say one hydrogen which is attached to the benzene ring will be substituted with the electrophile. So it is a electrophilic aromatic substitution reaction. So now we understood the general mechanism of the electrophilic substitution reaction. Now let's go to the first one. Halogenation reactions. We know what are the halogens: chlorine, bromine, iodine. Yes, no. So halogenation reactions, when we take benzene, the halogenation reactions takes place in the presence of aluminium chloride, or so these act as a catalyst. So our aluminium chloride, so here we can say benzene reacting with chlorine in the presence of a catalyst like aluminium chloride, it will give chlorobenzene and HCl is removed. So this is the product which mechanism we will see next. So first step, is the formation of electrophile. As I already told, so we want a strong electrophile. As chlorine is not a strong electrophile, to make it strong, so what happens, it reacts with the aluminium chloride, which is a catalyst. So as aluminium chloride, it is an Lewis acid, it will accept electrons which is given by chlorine and it will form a complex. So after this formation of complexation, it will become more electrophile. So here we can see Cl, Cl plus. This Cl will give electron to the aluminium. So it will have positive charge, and aluminium, by receiving an electron, it will have negative charge. So it will form Cl, Cl, Al, Cl, Cl3. So it will form a complexation is formed. So after a complexation is formed, we will generate a more electrophile, or the more strong electrophile. So that is the first step, formation of electrophile. Next, second step is this electrophile will be attacked to our benzene ring. So benzene ring will be attacked with the complex formed in the first step. So this here, the chlorine will be, this chlorine will be attacked to the benzene ring. So it will give chlorine here positive charge, and it will form a resonance stabilized cation, as I told in the general mechanism before. So it will give a resonance stabilized cation. Why it is giving a resonance stabilized carbocation means it have 3 double bonds. So it can break any bond. If it breaks here, one resonance stabilized structure, or if in this position or in this position. So 3 resonance stabilized carbocations are formed, which we can also say sigma complex. So we can see here the attack happened. So here positive charge, 2 bonds are here. Again here, so here it is attacked. So here 2 bonds here. So the resonance stabilized structure is formed after the electrophile attack. Next, step 3 is, so I already told, when an electrophile is attacked, so what happens, it will lose its aromacity or it will lose its stability. So this benzene will do something to restore its aromacity. So it will do it by removing one proton. So the step 3 is restore aromacity. So here I took one resonance structure. So already hydrogen which is there in the benzene ring will be removed by AlCl3, which is present in that complex. So here the proton will be taken up by the AlCl3. So leaving benzene chloride plus HCl plus AlCl3. So like this we will get a regenerated catalyst again. So like this we can say, and I already told the hydrogen which is living here is a weakly acidic. So here it formed HCl, hydrochloric acid, which is a weakly acidic. So this is about halogenation reactions. Next is nitration reaction. So nitration of aromatic compounds, we will see first general scheme. Benzene attacked with the nitric acid HNO3 and H2SO4 sulfuric acid acts as a catalyst. So to form NO2 here, so nitrobenzene plus water. So here H2SO4 acts as a catalyst. As we know, nitric acid is not a strong electrophile. We want a strong electrophile for the aromatic substitution reactions, because benzene is a very stable compound. So here nitric acid, generation of electrophile or formation of electrophile is the first step, as we seen in the last step also, in the last also. So here nitration. So HNO3 here what happens, reacts with sulfuric acid. Here see, there will be a proton transfer happens. So we will get NO2 OH2. So here H is taken up here. So again the leaving group get dissociated. So H2O will be, this one will be dissociated to form NO2, nitronium ion. So this is a strong electrophile which we want, nitronium ion. So this nitronium ion, now in the second step, which is electrophilic attack, which it attacks to the benzene ring. So we can say electrophilic attack here in this position NO2. So to form a resonance stabilized carbocations, same like before. So resonance stabilized cation, which is a sigma complex, is formed. Again here it will lose its aromacity as usual, and to restore this it will lose proton. So same, this proton will be removed by the OSO3H which is present here. Again here it lost this one, so the remaining is there, no? So from this again this proton will be restored. So we will get nitrobenzene along with that H2SO4, and so this is the last step. So we got nitration of aromatic compound, benzene, nitrobenzene we got, and this next is sulfonation of aromatic compound. Here also the same general scheme as we discussed. So benzene reacted with SO3 in the presence of sulfuric acid, which is a catalyst. So we can say it will form sulfonic acid product. So HSO3. Yes, no? So what is the first step? As usual, formation of electrophile. So this SO3 reacts with the sulfuric acid. Proton transfer will takes place. So what happens? From this H will be transferred. So what happens? SO3 OH SO4 minus. So by losing this it will get a negative charge. Here we will get a positive charge. After this it will become a strong electrophile. It will attack the benzene ring. So we will get again 3 resonance structures. So SO3OH will get. After that it will lose its aromacity, same as usual, and to restore the aromacity again proton will be lost. So proton will be lost here to form again sulfonic acid. Proton transfer takes place and H2SO4 is formed. So it is also, it is a let's wind up with the electrophilic aromatic substitution reaction. So benzene reacts with chlorine in the presence of FeCl3. So it is a halogenation reaction to form chlorobenzene. So and it reacts with nitric acid in the presence of sulfuric acid, and it is a nitration reaction to form nitrobenzene, and it reacts with SO3 in the presence of sulfuric acid. So it is a sulfonation reaction to form SO3H reaction, and I was already told it is a reversible reaction in the presence of water or sulfuric acid. Again it will be reversed. So next is Friedel-Crafts alkylation and Friedel-Crafts acylation. I will do it in the next video because it is a little more complex than these 3. So subscribe to see the next video also. Thank you.